grade 9s, and welcome to another video on factorization, one of the biggest chapters that lots of students struggle with, and it is actually so simple to do. You just need to practice it and you need to understand why we do factorization. Okay, so the main reason up to now we've learned about simplification. Simplification is when you take away your brackets. Like if you've got 2 times x plus 3 in brackets, you want to distribute that 2 inside. So in actual fact, you are making one term many terms. Like for example, if I've got 2 times x plus 8. So if you've got that, you would say that it's 2x plus 2 times 8 is 16. So can you see that we've made one term into 2 terms? Okay, so more than one term. And basically simplification is taking your brackets away. So now we're going to teach you the opposite. We're going to teach you how to factorize. So to me, the factorization is like seeing it as the opposite of simplification, because we are making many terms one term and we are bringing brackets back. So for instance, I would give you 2x plus 16 and I would say factorize the following, and you would take out a 2 and what is left? X plus 8. All right, so this should seem quite easy as we go along, but can you see that what you ended up with here in your simplification sum is what you start with in factorization? And then we factorize by making 2 terms over here, one term. Okay, so in the summary, making many terms, one term. We're bringing brackets back. Yeah, okay. So these are the different types. So if I had to say to you, these are the simplification that you've learned up to now. Just want to make it a little bit, sorry that it's not so thick. Okay, so you've learned about how to simplify these 2 terms. X times x is x squared minus 4x plus 4x minus 16. So hopefully you know how to do this by now, foiling. And then you can see that this middle term will fall away and you're left with x squared minus 16. Okay, with factorization, what you ended up with here, we give to you and we say factorize. Okay, so I'm going to teach you now how to do that. And then the last one, if you had to FOIL 2 brackets, x times x is x squared plus 2x plus 3x plus 3 times 2 is, so then you've got x squared plus 5x plus 6. So what you see on the left-hand side is simplification. This is what you've done up to now. All right, so simplification, we started off in grade, let me just close that bracket, sorry. We started this off in grade 8 already, and then grade 9, we introduced 2 brackets to you when they multiply, and then, or multiplying with binomials, and the same with the last bracket. Now, what is interesting about this middle bracket is the 2 brackets look exactly the same, except the one has a plus and the other one has a minus. So that is what you do with this one. So, but I'm going to explain everything in depth. You always split the minus into a minus plus, and then if you square root x squared, it will give you the x. Sorry, I jumped a little bit ahead. And if you square root the second term, that would give you the second term's position there in the brackets. Okay, so can you see that I ended up with what I started with? Sorry, this thing is changing with what I've started with there. Okay, and this is what we call the difference of 2 perfect squares. And then I'm going to go into each one in depth just now. This one is what we call a trinomial. So can you see what I ended up with? Sorry, what I ended up with here is what I start with over there. when I say to factorize. And then you would always put it into two brackets, and then the x splits. The x splits. The signs are the same. They're both positive. And what times what gives you 6? Sorry, I don't know why this one keeps on changing to the... what times what gives you 6? If you add or subtract, it gives you 5. And that is 3 and 2. All right, but I'm going to explain everything nicely, slowly with each section. So what you can see here, if I just have to bring this back, is that factorization in grade 9, we've got 3 types. We've got HCF, we've got a difference of 2 perfect squares, and we've got the trinomial. So with factorization is 3 main types of factorization. We're going to start with the highest common factor. So what I'm going to do on the left hand side is simplification, and then on the right hand side is the factorization, just so that you can see how we move from the one to the other. Okay, so in grade 8 you were able to simplify all of these. Okay, so if I had to simplify, I would be left with 5x plus 5 times 4 is 20. All right, now we want to go and work backwards. So if I give you 5x plus 20, you're going to, and I say to you, factorize the following. You want to end up with what you've got there. And how that works is, you're going to look at both terms. I've got a 5x and a 20. And you're going to take out the highest common factor. So on this side, sorry, I don't know why it keeps on erasing it. On this side, I've got a 5 and an x. And on this side, I've got a 20. So what is the highest number that you can take out that is nicely divisible with 5x and 20? I hope you can see that it is a 5. Because if I take out a 5 and I divide each side with 5, I'll be left with nice whole numbers. And that is what you write up, what is left. Sorry. X, 5. You take out a 5, and what is left? X plus 4. Can you see that's what you've started with on that side when I said to you simplify? And then you ended up with that. And now we give you this part. 20. Now we give you this part and we say to you, factorize it again. Bring it back to one term. All right, if I had to simplify here, I'll be left with 6 times 3 is 18, x squared y, plus 6 times 4 is 24, x. Okay, so can you see on the other side, if I had to give this to you and say to you, factorize the following, then you will say, all right, I need to find a number that is neatly divisible by 18 and 24. And what do you think that would be? That would be a 6. Because if you take 9, 9 can't go into 24. So it is a 6. Now I've got an x squared. And I've got an x. Sorry, I don't know why it keeps on. I've got a new pen now at last. But now the pen keeps on erasing and I don't understand why. Okay. That was plus 2 plus x. All right, I hope that was the original. Plus 24. Sorry, that should be a 24. This was a 24x. All right, so between 18 and 24, what is your highest number you can take out? 6. Then I've got an x squared and I've got an x. And the x to the power 1 and the x to the power 2, you're going to take out the one with the lowest exponent. Okay, for the highest common factor, you take the one with the lowest exponent. So an x, can you take out a y? No, because there's only a y. There's only a y here on this side, and there's no y's on this side. So you cannot take out a y. It's not common in both. And now we're going to take 6x and divide it with both sides. And that is what's going to be left. All right, so 18 divided by 6 is 3. X squared, divided by x gives you x. Y, if there's nothing to divide out with, it stays there. Plus 24. So 24 divided by 6 is 4. 24 divided by 6 is 4. And the x and the x cancels out. So can you see that that is the original simplification sum that was given there? Okay, I'm going to go a little bit faster. Over here, if you had to simplify it, it would be 4x to the power 3, y to the power 4, plus 2x to the power of 5, 4, y to the power of 5. Okay, that was simplification. Now over here, if I had to ask you to factorize it, you would take out the highest common factor. Between 4 and 2 is 2. Then there's an x to the power 3 and an x to the power 4. You take out the one with the lowest exponent. And y to the power of 4. What is left? 4 divided by 2 is 2. X to the power 3, x to the power 3 sort of cancels out over there. And the y to the power 4, y to the power 4 cancels out. Plus, now it's this term. So it's this term over here that I'm going to divide now with the 2x to the power 3y to the power 4. So I'm just going to rewrite this so you can see that was the original that I took out. And 2 divided by 2 is 1. X to the power 4 divided by x to the power 3 is x. Y to the power 5 divided by y to the power 4 is, was that a 2? Plus 2y. Okay. Sorry. Now I just need to quickly look over here. Okay, sorry. There lies an HCF of 2 that I could have taken out. So that's why it doesn't end up the same. Okay, but this side is still correct. The factorization part, exactly like it is there. So that is what would be left. Okay, so over here, if you had to simplify, you would say 2x to the power of 4, y to the power 2, z to the power 2, plus 2 times 2 is 4, x to the power 3, y, z, minus 2 times 3 is 6, x to the power 4, y, z. Okay, and over here, if you had to factorize between 2 and 4 and 6, what is the number that is divisible with all of them? A 2. Then I've got x to the power 4, x to the power 3. X to the power 3, x to the power 4. So you take the one with the lowest exponent. I've got a y squared, a y1, and a y1. So I'll take out y1. I've got z2, z1, z1. So I had to take out only a 2. Sorry. This one shouldn't be there. Okay, now what is left? So you're going to take each term on top here and divide it with what you've taken out. So let me do another color so you can see nicely. So I'm going to take this and divide it with what I've taken out. So 2 divided by 2 is 1. X to the power 4 divided by x to the power 3 is x. Y squared divided by y is just 1y. Z squared divided by z is z. Plus, now I'm going to take out, I'm going to divide this with what I've taken out. 4 divided by 2 is 2. X to the power 3 divided by x to the power 3 will fall away. Y over y falls away. Z over z falls away. And then let's do another color. Then we're going to divide the last term away. A minus comes down. 6 divided by 2 is 3. X, y, and z falls away. And then you're done. All right, I hope it makes sense. Highest common factor is quite easy. I think if you know your times tables, if you were forced to do your times tables when you were younger, Okay, now the difference of two perfect squares. I'm first going to do the simplification side, and then we're going to move over to the factorization side. Okay, so over here, this would have said simplify, and this would have said factorize. Okay, so simplify, very quick. X times x is x squared minus 5x plus 5x minus 25. So what I want you to note is that all of these brackets are exactly the same, except for there's a plus and a minus in the bracket. Okay, and these are what we call difference of two perfect squares. So this one will also end up x times x is x squared plus 3x minus 3x will fall away, and a negative times a positive is a negative 9. So all of these, 2x times 2x is 4x squared. Then it would be, I'll just write it down, minus 2x plus 2x, which will always fall away, minus 1. So then your final answer, 4x squared minus 1. 4 times 4 is 16x squared. The middle two terms will fall away, minus 81. 9 times 9 is 81. So what I want you to note is that you always have what was given. It was always two brackets that had exactly the same figures in it, except for a minus and a plus, or a plus and a minus. Then we know that the middle term will always fall away, and you'll be left with the front term that was multiplying the two of those together, and the back term that was multiplying the back two parts together. All right, so when you've got the difference of two perfect squares, it's all in the name. It's the difference, which means it's the minus the difference of two brackets that are perfectly square rootable. So what that means is that you must be able to square root both sides beautifully. There must be no fractions, half numbers, anything like that. So the way we always set it up is two brackets. Inside the two brackets, a plus and a minus. In the first position, you square root the first term. And in the second position, you square root the second term. Easy as that. With this one, I see it's a difference of two perfectly square rootable sides. So I know that it's going to be two brackets. A plus and a minus, or a minus plus, it doesn't matter. The x splits. Sorry, the square root of x squared is xx, and the square root of 9 is 3. And then you're done. So you can see it's always the opposite of simplification of what I've done there. Over here, it's a difference of two perfect squares. Please remember that one is perfectly square rootable. Okay, you have a plus and a minus. Square root of 4x squared is 2x. Remember, you square root the number as normal. And if there's an exponent, it's inside over outside. If there's nothing there, there's also 2 over there. And 2 divided by 2 is a 1. Square root of 1 is 1. Sorry, and that 2x also had to go in there. And that's it. Okay, with this one, you've got two brackets with a plus and a minus. Square root of the first term goes in the first position, which is 4x. And the square root of 81 is, and 9. And then you're done. Hey, that's not too bad. And then we get the last type of factorization, and this is trinomials. So if you look on the simplification side, so this again would have said, simplify. And this would have said factorize. Okay. Factorize, we give you many terms and you have to make it one term. In simplification, we give you one term, and you're going to simplify it by losing those brackets by multiplying out. Okay, so if I had to do this, x times x is x squared minus 3x plus 2x minus 2 times 3 is 6. And then you're left with x squared minus 3 plus 2 is minus x minus 6. Okay, so can you see that always when I have two brackets, with doesn't matter what's inside, plus, minus, different numbers, that you'll always end up with a trinomial. Tri means three terms, and it's always something squared, something x, just a number. Again, something squared, something x, just a number. So if we had to simplify this, I'm just going to go a bit faster, is x squared plus 2x minus 5x is minus 3x. And a negative times a positive is a negative. 5 times 2 is 10. Okay, x times x is x squared minus 4x minus another 4x is minus 8x. And a negative 4 times a negative 4 is a positive 16. Okay, and last one. X times x is x squared plus 5x plus another x is plus 6x. And a positive 1 times a positive 5 is a positive 5. Okay, always a trinomial left. Now, how do we set up these brackets if the trinomial is given and you need to set up the brackets? Let's quickly have a look. So with this, you need to recognize this is a trinomial. So I'm going to set it up with two brackets always, everywhere. So when you see something x, something, some x squared, something x, just a number, then you know this is a trinomial. Something squared, something x, just a number. Again, trinomial. So you set up your brackets. All right, so in grade 9, we always start off with a 1x squared. Sometimes, to make it a little bit difficult, we start off with a negative x squared, but regardless, it must be a 1x squared. If there's something in front of it, in grade 9, it will be able to be taken out with an HCF. So yes, you always start with an HCF. Always see, can I take out a number that is common everywhere so that I can make these values a little bit smaller? And if there is a trinomial with a number in front, it means that you have to divide with that number all throughout by taking it out. Okay, but we'll get to those examples later. Okay, so if you've watched my previous video on trinomials, factorization, this is the most watched video. I think it's everybody struggles, or they don't listen in class and then they feel, okay, shoot, I need to know this. Then they go and see, but how do we do this actually? So then I always say to my kids, just listen from the beginning. Why don't you just from the beginning listen well and just know how to do it, and then you never ever have to worry, stress, or anything after that. So listen this first time and then it's over and done with. Okay, so you always start by your signs. I always start with the signs. Let's set up our signs. The second sign, you start with that one. If it is a negative, it means that the signs are going to be different. Different meaning either a plus or a minus and a plus. Okay, so different means plus, minus, minus, plus. Which one goes first? The negative always then. This first one always goes first. So it's going to be minus and a plus. Okay, signs are done. Then you're going to ask yourself, what times what gives you 6? So basically, what are the factors of 6? It's 3 times 2, 6 times 1. If you add or subtract those numbers, it gives you this middle term. And if there's nothing, there's a 1. So if you say 6 plus 1, it will give you 7. If you say 6 minus 1, it gives you 5. So there's no way of taking a 6 and a 1 and making it into a 1. But there is a way to make, the 3 and the 2 become a 1, because 3 minus 2 gives you 1. And then you always write the biggest number first. So 3 times 2 gives you that 6. And minus 3 plus 2 gives you that -1. And then in the front, there's that x. He's just going to split. So basically, you're always going to start off with the x. Okay, so you always split that x squared, because when you FOIL, x times x is x squared and x. All right, so now I've written all the 4 different scenarios that you can get. So you go to your second sign and see whether it is same or different. It is different. Now, which one goes first? The minus goes first. What times what gives you 10? If you add or subtract, it gives you 3. And that would be a 5 and a 2. 5 times 2 gives you 10. Minus 5 plus 2 gives you -3. Okay, so there's a quick way of testing this. And please, you need to test your answers. Can you see if you had to FOIL this out again? X times x is x squared, plus 2x minus 5x gives you -3x minus 10. So your factorization, you can always test whether you've done it correctly. But if you want to do it a short, quick way, you say minus 5 with the sign plus 2 does give you that -3. Minus 5 plus 2 does give you -3. If you do -5 times +2, it does give you that -10. So you can test it straight throughout, just quick to see whether you've done it correctly. Okay, over here, the signs are the same. If it's a positive, it means it's the same. And that's easy. They are both going to be negatives. Here, the signs are the same. What are they the same of? They are both positives. Easy, nay. So yeah, if it was different and this one was a plus, and this one was a plus, then they would have been different. They're different. You start off with the plus. So it would have been plus minus over there. What times what gives you 16? If you add or subtract, it gives you 8. 4 times 4, yes. 4 times 4 gives you 16, and minus 4 minus another 4 does give you that -8. Sorry about that. Okay, and over here, what times what gives you 5? If you add or subtract, gives you 6, and that is 5 times 1. Because plus 5 plus 1 gives you that +6. And if you multiply +5 times a +1, it does give you that +5. Okay, so let's quickly have a look at the different types that you can get. Let's do a few over here. Oh no, see, I carried on with the trinomial. Sorry, it carries on. Okay, so I'm not going to do the simplification, but in actual fact, what I did is with each one, I've done the opposite over here. So if you had to FOIL this out, you'll be left with x squared minus 6x plus 4x gives you -2x minus 24. So you'll see that I've given you the opposite. So when you simplify these ones, it will give you these ones that we are trying to factorize. Okay. Let's get a lacquer color over here. All righty. So we're going to start. It is a trinomial. Something squared, something x, just a number. The x splits. They are different. The first one is a minus. What times what gives you 24? If you add or subtract, it gives you -2. Then it gives a 6 and a 4. Always write the biggest number first. Because a -6 plus 4 does give you that -2. And a -6 times a +4 gives you that -24. Okay, over here, they are different. The x always splits. They are different. The first one's a minus and a plus. And what times what gives you 16? If you add or subtract, it gives you 6. And that is 8 times 2. test yourself. Minus 8 plus 2 does give you that negative 6. And a negative 8 times a positive 2 does give you that negative 16. Over here, 2 brackets because it's a trinomial. The x splits. They're the same. They're both negatives. And 7 times 5 gives you 35, and 7 plus 5, sorry, gives you 12. So 7 and 5. Always write the biggest number first. Over here, 2 brackets. The x splits. They are the same. They're both positives. And what times what gives you 30? If you add or subtract, gives you 13, and 10 times 3. Just test yourself. Plus 10 plus 3 gives you plus 13. Positive 10 times a positive 3 does give you positive 30 over there. All right. And that is your trinomials. So over here, let's just quickly look at the mixed examples if you want to. They do get a little bit harder, and I'm going to explain it nicely to you. All right. So what you see here with A is 2 terms. Now with 2 terms, it's a difference of 2 perfect squares or an HCF. Always start with an HCF because you can immediately see this is actually not a difference of 2 perfect squares because they cannot be perfectly square rootable on both sides. So we're going to take out an HCF. So between the numbers, what is the number that's divisible with both terms? A 13. If there's a 2 C's, you take the one with the lowest exponent. So what is left? 26 divided by 13 is 2. C to the power 7 divided by C to the power 6 is just a C. Minus comes down. 13 divided by 13 is 1. C to the power 6 divided by C to the power 6 is 1. And the D comes down because he's got nothing to divide with. And there you've made 2 terms into 1 term. All right, now these ones are a little bit more difficult to see. With your HCF, if I had 2x minus x squared, then I would have easily said, okay, I need to take out an x, and what is left? 2 minus x. Okay, now the same with these ones. I'm going to take out a highest common factor, but now it is a bracket. So can you see these 2 brackets are exactly the same with both terms? So I'm going to take out an a plus b bracket. And then what is left? Can you see that it's a 2 minus x? Like that. All right. Then we can also group terms together. So if there's nothing that is common all throughout, like here's an x, there's a y, there's a y, then I'm going to group the 2 together. Just very important. I can just go and put brackets around because there is a plus over there. In grade 10, then we've got negatives over there. So we need to change this sign over here. Okay, but that would be more for next year. All right. And then you're going to factorize each bracket. You're going to say over here, I can take out an x. What is left? A plus b. Plus over here, I can take out a y. What is left? A plus b. And now can you see it looks like this previous one where I take out a common bracket, which is a plus b. So with this term, I'm going to take out an a plus b, and the other term, the next term, I'm also going to take out the a plus b. So I'm going to take out that common a plus b, and what is left? X plus y. So let me just make a nice bracket, x plus y. And then we've made 4 terms into 1 term. Over here, there's 1 to the power 2, and there's a bracket to the power 1. Remember I said you take out the one with the lowest exponent. So I'm going to take out x minus y, and what is left? 2 times x minus y, because over here there's still 1 left, and then a plus 3. And then I always sing, clean up, everybody clean up. So then you clean up inside your bracket by simplifying a little bit. And that is then your final term. Okay, making 2 terms, 1 term. Over here with the common bracket, can you see that I've got an x plus 1 and a 1 plus x. Now, it looks the same, and they actually are the same if you just swap that one around. And if you do that, then you'll be left with 2x, x plus 1 minus 8x plus 1. Why can you do that? Because 2 plus 3 is the same as 3 plus 2. And that is why you can just swap it around. So if they're both positives, you are allowed to just swap them around. And now you're going to take out a common bracket of x plus 1. And what is left? 2x minus 8. Okay. Now this one is a little bit difficult. It's a little bit different. Some textbooks in grade 9 only do it in grade 10. No, sorry. We start with this in grade 9. So now, can you see the brackets look very similar, but they're not exactly the same. So in my previous one, I said swap them around. But now if you swap them around, remember that the sign must go with him. So that is what you will be left with. So step 1, swap it around so that we at least have the 2x first and then the 1. Although be it in this one there's a minus 1 and in that one is a plus 1. So I'm going to do it slowly. Later on you'll see that you'll do it all somewhere in one where you swap and change the sign. Okay, now the next step is that we actually want to make this negative 2 into a positive 2. So those two brackets will become the same. We want to make this positive 1 a negative 1. And we actually can by changing that sign over there. Then we're left with x times 2x minus 1. And the positive, we make a negative. And what that does is it rolls out and it changes all the signs thereafter. So by changing that sign, I always say it rolls into the bracket and it changes all the signs inside the bracket thereafter. So the negative 2x becomes then a positive 2x, and the positive 1 will become a negative 1. And now we've got the common bracket of 2x minus 1. And that is what I'm going to take out as my highest common factor. Okay, what is left? X minus, and if you've taken out exactly the same amount as what was there, then what you will be left with is a 1. Because 2x minus 1 divided by 2x minus 1 gives you 1. Okay, difference of two perfect squares. Can you see it? See it, hear it in the name. Difference of two perfect squares. So we're always going to set up two brackets with a plus. Get the hang of this now, with a plus and a minus. Then if you square root the first term, it will give you 2x. And if you square root the second term, it will give you 6. And then you're done. Aha, trinomial, something squared, something x, or something squared, something y, just a number. But now, remember I said to you that we never start with a 2, or we always start with a y, 1x or 1y. That means that surely I must first take out an HCF of 2. So is 2 divisible with all 3 terms? Yes, it is. So I'm going to be left with y squared plus 5y plus 4. And that will give you bring the 2 down. He comes with his buddies. He comes down, don't just drop him somewhere. And then I've got the y that splits. They are the same. They're both positives. And 4 times 1 will give you 4. And plus 4 plus 1 gives you 5y. And then you're done. Over here, again, we don't ever start off with a 4. We start with a 1, let alone a negative 4. So I'm going to divide away with a negative 4 everywhere. So I'm taking out the negative 4. And then what is left? A negative 4 divided by a negative 4 gives you an x squared. Positive 20x divided by negative 4 gives you negative. 20 divided by 4 is 5x. And the plus divided by minus is a minus. 24 divided by 4 gives you 4, 8, 12, 16. No, gives you 8. No, 6. Sorry. I'm really tired. Sorry. Does that? Gives you 6. And now the negative 4 drags along. He comes down in your answers. The signs are different. The first one is a minus. Okay. The x splits over there. And what times what gives you 6? If you add or subtract, it gives you 5. Okay, now very important with this one. Let's say you chose a 6 and a 1, because 6 times 1 does give you negative 6. But then you need to go test it. Minus 6 plus 1 does give you a negative 5. So I've started off with the correct one. Sorry. I want to quickly do the wrong one. So if you decided on 3 and 2, because 3 times 2 does give you a negative 6, and then you had to test the middle term. Minus 3 plus 2 gives you a negative 1. It doesn't give you that negative 5 over there. So then you know that you've chosen the right one, especially with this little sneaky one. It could be a 6 and a 1 or a 3 and a 2. So in this case, it was a 6 and a 1, because minus 6 plus 1 does give you negative 5. And a negative 6 times a positive 1 gives you a negative 6 over there. Okay. This one, they give it to you a little bit demakar. You have to reshuffle it as long as the sign goes with his buddy. So minus 12x plus 16. Again, we never start off with a 2. It always has to be a 1. So that means everything should be divisible by 2. So then you're left with x squared. Sorry, I take out a 2. Don't forget about that. Then I'm left with minus 6x plus 8. Your answer comes with 2 brackets. They are the same. They're both negative. The x splits. And 4 times 2 gives you 8. And minus 4 minus another 2 does give you negative 6. Okay, over here, sign change and swap. And this is our last one, guys. So we're going to swap it around. Why? Because we want it the same as this bracket so that we can take out a common bracket. 16x squared m minus n plus, and if you swap them around, remember his sign, buddy, it would be negative 5 plus n. And now we're going to change the sign, and what it does, it rolls out to change all the signs inside the bracket. The plus becomes a minus, then the negative m becomes a positive m. and the positive n becomes a negative n. And now we've got a common bracket, m minus n. And if you take out the m minus n, what is left? 16x squared minus, and if you've taken out the same thing, your answer would be 1. But now, very, very important, can you see that what is left? You always have to ask yourself, can I factorize any further? And I hope that you could see that 16x squared minus 1 is a difference of two perfect squares. So this m minus n drags along, and this bracket could have been splitted into the difference of two perfect squares. In this brackets would be a plus minus, and then it would be 4x plus 1 and 4x minus 1. Why? Because the square root of 16x squared is 4x, and the square root of 1 is 1. Okay, so now I just want to quickly show you why on earth do we go and teach you again how to factorize. If you've got a 2 plus 4 over 2, you cannot go and say the 2 and the 2 cancels out and that gives me 4. Doesn't work like that, because in actual fact 2 plus 4 is 6, and 6 divided by 2 should give you 3. So this is and this one is yes. Okay, wrong and yes. So that is why we teach you factorization, because if I had 6 over 2 and you had to factorize the 6, you can squish it into 2 times 3 over 2. And can you see that if it's 2 terms, you can't, but if it is 1 term, you are more than welcome to go and cancel that out. So please take note of why we do factorization. All right, so let's quickly have a look at the sums that are awaiting you when you are done with factorization and why on earth we do factorization. So if I had to give you this, 2x plus 4 divided by x squared plus 5x plus 6, then you would have told me, well, there's nothing really I can do, can't cancel out. But we're going to actually further factorize with the use of we're going to further simplify with the use of factorization. So what you're going to do is, let me use another color. You're going to factorize the top. You're going to factorize the bottom. So you factorize where you can. At the top, we can clearly see it's an HCF. We're going to take out a 2. And at the bottom, hopefully you can recognize now it's a trinomial. So let's go ahead and do that. So if I take out a 2, I'll be left with x plus 2, 2x plus 2, all over. A trinomial is always 2 brackets. They're the same. The first one, or they're both a plus. And what times what gives you 6? If you add or subtract, it gives you 5. And let's say you chose 6 and 1 by accident. Then you test yourself. Plus 6 plus 1 gives you 7 and not a positive 5. So it can't be those two. Let's do the 3 and the 2 and test it. Plus 3 plus 2 gives you a positive 5, and if you multiply them, it gives you that positive 6. And now, because they are all one term, you are more than welcome to go and cancel out those 2x plus 2's, and you are left with 2 over x plus 3. So you'll see this is where we are heading towards. This is what we want you to do at the end of factorization. And purely, it's always what we use factorization with is to simplify further. So please, please, please note this is where we are heading. It's very important to be able to factorize confidently and quickly, and to recognize those 3 types that you get: the HCF, the difference of two perfect squares, and the trinomial, and how to factorize them. So the HCF, you always take out what is common, and what is left is inside the brackets. With the difference of two perfect squares and a trinomial, you always set up 2 brackets, and then you do your thing. All right. Thank you so much for watching. I know it's a long video, but lots of you struggle with this section, and I just really hope that you fly through factorization and that it's an easy section for you. All the best, and thank you for watching. Goodbye.